Hi guys, hello, good morning. Welcome to our second live maths. So I'm Paul, thanks very much for watching, thanks for following me. Subscribe to this YouTube page if you haven't already. Follow me on Instagram, Paul Tutors Maths. We're here, it's tough times, the exams are gone in the bin and we're struggling to keep up some sort of motivation, probably. Or maybe some of you are just passionate mathematicians doing it day in, day out, but probably a lot of you are needing a bit of a boost. So I am here. I'm here to be your maths teacher. Just in little blasts, 2 questions every day, 10 o'clock, exam style questions, still an edXL A-level syllabus at the moment. Let's see how we get on with that. We could change to some other ones. And let's keep you fresh and let's keep you going, okay? Because it's not just for the exams. Maths is, if you go to university or at some point in the future you're going to come across another maths module that's not A-level, this is good stuff to know. Differentiation, integration, and all of the topics actually in A-level. I'm going to stop banging on about it now and I'm just going to start going, all right? We get in here, we get out fast. 20 to 30 minutes, 2 questions. First one's an AS level question, second one's an A level question. Ready, steady, and get going. Prove from first principles the derivative of 3x squared is 6x. First principles. Didn't used to be in the syllabus, I think, certainly when I was a young lad. This wasn't getting bandied around in my syllabus. It was usually just do your differentiation. There it is, there's the answer. But now with the new specimen, the new syllabus, specification, they want you to actually understand what you are doing. So they don't want you to just plug stuff in, get out the other side, they want you to understand. So we're off, enough chit chat, we're off. And actually, let's start by drawing something. What we're going to do here, look at that. There's another point, let's put a point here. Okay, beautiful. Call that f of x. So right, basically, I'm making 2 points. All right. Well, okay, you might be panicking already because, oh, he's labeled the axes with letters. It's not numbers. So that's okay. Breathe and say two deep breaths and watch. Here is 1 point. There. And the coordinates for that are x, f of x. It's just a random curve I drew, by the way. It's nothing wholly special. Here's another one. I mean, I didn't get that 100% straight. That's all right, you get the point. Coordinates for this one, x coordinate x plus h, y coordinate f of x plus h. Okay, not too much drama so far. Oh, and by the way, we're going to call this h. So there you go. And, by the way, this ties in with functions, right? If you have a function, you plug in the x, and, if you plugged in 2 on the y coordinate, it would be f of 2. If you plugged in 6 in the y coordinate, it's f of 6. So, okay, we've drawn a little picture. It's a bit weird. Why have I called that h? What on earth am I up to? I am going to jump back to my GCSE days, and I'm going to draw a straight line. I'm going to do it like that. Wow. Absolutely beautiful. Picasso would be proud. What's the gradient of that line? What is the gradient of that line? Well, even back when we were just learning to walk for the first time, someone came along to us and whispered to us, rise over run. Rise over run. What's the rise here? Well, the change between those two y coordinates f of x plus h minus f of x. You okay with that? I mean, there you go, that's your top one. That would give you the full height, and if you subtract off this height, f of x plus h minus f, there you go, that's your rise. What's your run? What is your run along the bottom? X plus h to the end, and x to there. So actually that little length is x plus h minus x, if you like. Fancy simplifying that? Yeah, we simplify that bottom bit a little bit. I mean, it's nothing mad, it's just a quick cancel the x's and you're left with that. And already some of the connoisseurs amongst you who spend their nights looking through the standard formula booklet for the exam will start to recognize that as looking like first principles differentiation. It's just the gradient of a straight line from GCSE with some funky letters put in that you need to learn about. One extra thing though, one last gasp thing, and this is where the magic happens, and it's really I think it was even Newton, well it's Newton and Leibniz, there's some sort of big discussion about who did it first. But this is the idea of calculus starting, of differentiation, is the idea of limits. So we're going to just, for example, imagine moving that point a little bit closer so that h got a bit smaller. And you've got a new point here. You could draw another straight line. Between those ones, might be something like that. Okay, so that's the same idea. And by the way, it's just random what I chose as x plus h here. I've brought it closer now, and I've drawn another straight line, and it's getting closer to looking like a tangent to the curve, which is what we know differentiation to be. And the goal of our lives for first principles is we're going to shrink that h to 0. So let me just write it out now. We call it the derivative, we end up calling it that, but it's the limit, as that h, this little guy here, the distance between the two, comes down and you shrink it to the 2 points on top of each other, h has gone to 0 and it's become a tangent. Okay, I've probably whittled on a bit too much about that. Well, no, that's not true. We do need to understand it, and you do need to know the theory behind what's happening. And it's actually quite beautiful. It's actually quite beautiful deep down when you get into it. All you're doing is taking 2 points, using your GCSE straight line knowledge, shrinking them together, and coming up with a derivative, just with this limit of h going to 0. Still haven't actually answered the question, but we've now got the backstory. We're ready to use this our tools, the arsenal that we've developed here. Here, our function is 3x squared. And by the way, we know the derivative is 6x. We might know that if we've started our AS level course. Multiply that 2 down the bottom and take 1 off the power, it's going to give you 6x. But how do we get there? We just plug it into the formula. Is it worth circling that, would you say? Can't totally hurt. Limit as h goes to 0 of. Now this is where people might think, well, I don't know. This is a step which can be a little bit dodgy for people. And we'll write it out first and then chat if required. Your function is 3x squared. So, everywhere there's an x, you need to put an x plus h if you're wanting to do f of x plus h, right? If it was f of 2, you'd have to put a 2 in here. If it was f of 12, you'd have to put a 12 in here. If it's f of x plus h, you have to put a x plus h in there, and it's going to look like that. This one, don't miss out the 3, is just the normal function, right? I mean, f of x, we've told you what it is. The question's told you what it is. I mean, it's not used, I guess the question's not used the term f of x, but it has mentioned it. Okay, chatting too much, let's keep going. Limit, h goes to 0 of, expand it out, x squared plus 2xh plus h squared minus 3x squared. You didn't just call that x squared plus h squared, did you, when you expanded it? Be unhappy with yourself if you did. Full expansion, FOIL, there it is. Limit, h goes to 0, 3x squared plus 6xh plus 3x squared. Now here, you could easily, or I could easily make algebra slips, or anything could happen. This is where all your hard practice of doing GCSE algebra or other algebra or whatever you've been doing really starts to pay off. Have you got it right? Let's keep going. Now, happy days. 3x's cancel, 3x squareds cancel. Just left with the two guys in the middle. 6xh plus 3h squared over h. Onward. Well, you can divide the h's through both of them. 6x plus 3h. And is it definitely 3h? Did I get all the stuff right? I think so, because that was h squared times 3, it should be 3h squared. I think I'm okay with that. And here is the grand finale, and for my final act, we take h to 0. And we do what we're saying up here. We pull the second point close to the first point, making h 0. And so that just means you're left with 6x, because this h has gone to 0. Quick recap. They came at us. They came at us hard and they said, differentiate 3x squared. They didn't just want us to do it, they wanted us to do it from first principles. So we busted out our formula. Maybe we learned about how to make the formula, we might not have. We don't necessarily need it, but for the new specification, for the new A-levels, they want you to understand what's going on. So you do well to have a look at this, try draw it out yourself, and see if you can replicate it. It'll take you a long way. It'll bring you to the formula. There it is. Plug in your stuff, just watch out for that f of x plus h. It's going to be plugging the x plus h everywhere there's an x into your function, and remember that's your function. So that's maybe all a bit fast, and I'm trying to do it quite fast and not spend too long on it for now. There could be extra videos coming to a YouTube account near you soon, something to watch out for. But anyway, once you've plugged it in, the rest is basically just algebra. You're expanding it out, cancelling what you can, ending up down here with your 6x plus 3h, taking h to 0, and it's done. Moving on. Let's see, let's get on to the next stuff. Give me 2 seconds, let's see if I can find a way to get this guy in. Mild technical difficulties. But yeah, so I'm doing one AS level question every day and one A level question. That was the one so far for AS. Although, I find that usually A-level people, by the time they've got to A-level, they might have not forgotten that first principles. They might have done it back in the day and then just put it out of their mind or not done it for a while. So it's very much one of those topics, I would say. So, okay, let's see. Where is this guy? This is the one. Okay, quite a lot of words here. I'm going to have to use my limited page space to do it. I am up for the challenge, I can tell you that right now. Right, okay, here we go. Trig modelling question. Now, this is the kind of thing that starts happening as you get into A-level and the new ones, modelling questions. They love it. Those exam writers are just overjoyed with the concept of not just making you do the stuff, but putting it into the real world. And here we've got boats in a harbour, or no, depth of water in a harbour. Yeah, depth of water and boats coming in and out. They just really want to solve the world's harbour problems, one boat at a time. So they're here. We're here to help them. We're here to use our techniques. Let me just write it out first and try not whip too much, because it can and frequently does happen. And really, we just want to get the maths done. I hope you've got sort of paper and pen there yourselves, trying it out. That's what we want here, all right? Get in here with a pen and paper, get it done. Get it done with me. I'm here to motivate you. I'm here to help you. Okay, let's calm down. So that's the model. D is the depth of the water, and T is the time. And it's the time after midnight, and it's the time after midnight in hours. All these sort of things can be just important to read and pay attention to. They're partly testing. Are you reading this thing properly? Are you paying attention to all the fine points? Maybe you can do the trigonometry. Can you actually pull off the final couple of stages to get the marks? Anyway, find the depth of the water when the boat enters the harbour. Well, so when it enters the harbour, so this is for part A, it's at 6:30, so we're going to put in T equals 6.5, right? That's about the gist of it. D equals 5 plus 2 sine 30 times 6.5. Bust out your nearest calculator. Now it looks to me like 4.48 meters. Just check I've done that okay. The depth, when it enters the harbour, it enters at 6:30. So that's 6.5 hours after midnight, plugging in 6.5, putting it into my calculator, hoping for the best. It's 4.48, part B. We're warmed up. They gave us a 1 marker to warm us up, and now they're really wanting us to go to hell and back with this one for 4 marks. Find to the nearest minute the earliest time the boat can leave the harbour. The earliest time it can leave. Okay, so let's just write down what we know. It can leave when? When water at least 3.8. Fascinating. Fascinating. So I would be unspeakably tempted. And actually, I know, no, I'm not going to talk. I was always going to go off into a big gallivant, but I'm not. I'm just going to get the thing done. And what I'm going to say to you is, in maths language, I could say that our thing, that's our equation for the depth, it's got to be bigger than 3.8. All right. So there we go. Take a moment, reflect on that. Convince yourself that that may in fact actually be accurate. You never know, I could have actually got it right. It does happen sometimes. Take away 5 from each side. Minus 1.2. Divide both sides by 2. Minus 0.6. So, quick recap, I did that a little bit fast. They want to know the earliest time the boat can leave the harbour. The question, if we'd spent time to read all of it, it's a mild sort of short story, but we can get to some of the key bits somewhere in there where it says it needs to be 3.8 meters deep before it can leave. Because remember, this function, this d thing, it's got a sine. And a sine graph is a kind of up and down bobby thingy. I think that's the official term. So it's going to go up and down. The height of this water is going up and down, bishy bashy Washingtons. and it can only go out on one of the up waves. That's what this thing's telling us, right? As this sine function is bobbing up and down, the boat can only leave at certain times when the thing's a certain height. So anyway, plug it in here. There's our function. We say it's bigger than 3 points because that's what they've asked for. And that is equivalent to this, to saying sine of 30t is big. Bigger than looks a bit like a 7 actually. That's pretty controversial stuff. When does a bigger than sign become a 7? That's for any philosophy students out there, get back to me on that. Bigger than minus 0.6. So it's now become, or at least for the next phase, it's become a solving trigonometry within bounds question. So this is kind of more of an AS level part of it. Remember the bounds, or you don't even have to remember, you could even just look between 0 and 24. All right, between 0 and 24, the bounds. So it's become a question of solving that between 0 and 24. So you start doing it if you know what to do. You can maybe even get ahead of me. I'm giving you a couple of seconds just to talk here. Use this chance to actually get ahead and try it yourself. You know, maybe don't listen to me because I'm banging on. I would distract you, but it is a good chance for you to get started on the question. I'm going. And always, this is the way I do these questions. People have different ways. The first cardinal sin is, well, don't put the negative into your inverse sign on the calculator. We're going to take an inverse sign. You're going to want to put that negative in. You guys, I just know you're sitting there thinking, I love putting negative into this inverse sign on the calculator. It's a hobby. You've made it into a hobby of yours. But this is how I'm going to do it instead. I guess the first thing, though, the way I do it is I multiply by the 30, because it's not just sine t, because it's 30t. The way I account for that is I multiply my bounds by the 30. So some have said 24 times 30 is 720. All right. I'm going to go a bit fast for now, and then we can maybe come back and check in on it. Then what I always do is I do the inverse of 0.6, just the positive number. So I'm doing inverse sine 0.6. It's telling me, it's alleging, the allegations are, that's your angle. My next part of my analysis is which quadrants are sine negative in. A couple of ways of doing it. You can do it with the graph, or you can do it with cast. You might not know what that means. All sine tan cos. Cast. That's quadrant 1, 2, 3, and 4. So if this is a bit funky for you, like I said, graph methods are fine. But anyway, right? Okay, let's keep going with this. So the letters tell you where the things are positive. So all of the functions, sine, tan, and cos are positive in quadrant 1. Only sine is positive in quadrant 2. Tan in quadrant 3, cos in quadrant 4. All sine, tan, cos. That's where they are positive. We want where it's negative. Analyzing that, or just thinking about a sine graph is your other method. Okay, quadrants. This is negative land down here. It's quadrant 3 and 4. Similarly, positive, positive for sine. It's these two where it's negative. Okay, excessive talking, more working. So when you do it, you're going to end up with 30t is, and okay, there's that greater than. So I talked about this a little bit on the quadratic inequalities yesterday. I'm not going to muck about with a greater than when I'm working out these numbers. I'm just going to keep it as equals, and I'm just going to examine that, and then we'll come back at the end and check how the greater than fits in. Because that's actually so key for these modelling questions, is that, again, it's a bit like the same problem you could fall into with quadratic inequalities. You just do all the algebra and think you're the, God's gift to maths. You're not. Sketching the graph is probably going to be the way you get to understand it totally. So anyway, right. Basically, quadrant 3 and 4. So to get the quadrant 3 answer, it's 180 plus 36.87, otherwise known as 116.87. And to get the quadrant 4 answer, 360 minus 36.87. It looks to me like 323.13. So that is the answers. Now I have to say, and actually I didn't really leave myself much room, but just for completeness, we need to get all the solutions up to 720. There's probably more, because they all repeat every 360. Sine, cos, and tan repeat every 360. We all were given a sine graph poster by our mothers to stick on our wall when we were children. And so we remember that they look like that. They keep going. Usually we look at them up to 360. But they're turned, and they go all the way negative as well, but that's taking up excessive drawing space. So anyway, we need to add on 360. 216.87 plus 360 gives me another solution. 576.87, and adding on to that one, 323.13. Eight, 683.13. Then let's divide everything by 30 now. And then we're going to have to stop and have a bit more of a chat, but you've got a bit of a chance to just check everything over here, check for any errors, make sure that all the calculations have been done correctly. I'm going to round that, better for worst. Yeah, we'll do that, 7.23. And you might be sitting there thinking, okay, I'm a bit rusty on some of these steps, or I can't quite remember how to do these parts. So maybe we can look at that in a bit more detail a different time. But for now, the exam questions have got so many levels to them that for this we can't focus on it. We need to be fast. 383.13 divided by 30. Okay. Remember, that's all in hours. And remember, that's all in hours after midnight. So, yeah. Quick recap before we get to the final stage of it. We're solving this within the boundary. We're really doing it within the boundary. I should put this in brackets because the real boundary is between 0 and 24. The way I do it, and the way I would recommend, it's not the only way. Not the only way. Okay, this is not. You're not in trouble if you don't do it like this. But if there's some multiple of t here, then I would times the bounds by 30. 0 times 30 is 0. 24 times 30 is 120. Hello. Now we're talking, and you're doing a negative. You're doing inverse sine of this thing, but you're not going to put the calculator in. You're not going to put the negative into the calculator. Please, please, if I can ask you one thing, it would be try not to do that, because you're going to suffer. You're going to suffer badly. Self-sacrifice. Better put the 0.6 in, get the angle, use cast or a graph to work out the quadrants where the thing is negative, 3 and 4, and then get your quadrant 3 and 4 answers off the back of that. Add 360. You might have to add 360 more times. I was a bit casual about that. I was just like, oh, we just add 360. You probably want to check. You might want to add 360 again. If you did it, it would take you above the 720, take you out of the boundary. Similarly, if you subtracted, it would take you out below 0, out of the boundary. So we've got to convince ourselves that's all the solutions. Divide it all by 30, so we get it in terms of t, as we wanted it. And now it's looking good. And you see how just nicely, by multiplying those bounds and looking for things between 0 and 720, I've picked up, once I've divided by the 30 at the end, I've picked up all stuff which is between 0 and 24. You know, I'm quite satisfied with myself, to be honest. It's nice, just, there it is. Did that multiplying with bounds, stretched it out, got my stuff, and then divided it by 30, and everything just fitted in. Okay, I think we're going to have to bring this to a close. It's been... I just get distracted, absolutely rabbiting on. So, let's finish it off and pull it together. And we're going to do it with a quick graph. Between 0 and 720, it's the equivalent. You've got 4 results here, so I'm just going to sort of write it draw it, and then you can maybe, let's try and move it along. You can maybe think about how I've got this. And let's see if we can just slowly piece it together. That's a sine graph. So let's say I'm drawing sine of 30t. This is up to 24 here, because that's what we were doing. Sine 30t, that's the graph we're dealing with, and we're doing it between 0 and 24. As it happens, it would look like this, and it would do 2 cycles. That would be 12, that would be 6, that would be 18. Minus 0.6. Now, we know, what's the y-coordinate of the high point? What's the y-coordinate of the high point, anyone? 1, okay? So the y-coordinate of the high point is 1, and of the low point is -1. We know that, we learned that in primary school. So, 0.6 is there. And you see what, well, okay, let's just do it. Let's do it first. Too much talking. And I'm just going to tell you that the t values we found correspond to the places where those meet. 10.77, that one there, 19.23, 22.77. This is the visual way of seeing what we've been up to. And that's the algebraic story. Sine 30t is bigger than minus 0.6 from 0 to 24. Here's the graphical way. Graph of sine 30t, line of minus 0.6. And where it's bigger, where the sine graph is bigger than minus 0.6, is things up the way. So if you like, I just sort of slightly shade out the bit below to let you know we're not interested. During that shaded area, in those shaded bits, the boat cannot leave the harbour. No chance. It's going to smash into the pier. Ice cream van is going to topple over. Casualties, potentially free ice cream. Not a total loss, but you're not going to get the boat out. So the only times it can come out is the stuff where it's above that line. So you know, you might want to think 7.23 is the answer. I guess this is where drawing the graph is quite important, because if you didn't do this, you just solved the equation, you might think 7.23 is the first time it can leave. I wouldn't blame you. I wouldn't sit here and blame you if you did think that, because you've done your trigonometry stuff, that's the first answer. But if you check it with the graph, there's 2 problems. Well, yeah, one, it's actually going to be below after 7.23. You see what I'm saying? 7.23 is an answer when they're equal, but actually it dips down below after that. So it's not going to have a great time leaving the harbour. And by the way, it comes in at 6.5, which is probably about there, which is above the level. But this is where, oh yeah, 6.5 I should write. This is where reading the question is really going to pay dividends. It says it enters at 6:30. It takes 2 hours to load its cargo. It takes 2 hours to load its cargo. Excessive. It's probably low. I can only imagine Paul Tudor's Maths t-shirts. Not available yet. Something to look into. Could also be loading Edexcel maths books, I imagine. There's a lot of people wanting them. 2 hours might not be enough time for that. Anyway, therefore, nothing can be earlier. You know, the earliest it could possibly leave is 8.5. And on our graph, 8.5 is somewhere between, you know, this was meant to be 6, and that's meant to be 12, 6, 12, so 8.5 somewhere in the middle here. Getting a bit messy, my little diagram, but somewhere there. So actually, it's on the up curve, and this point here is going to be the threshold. 7.23 is not enough. It's too early. So the first one it can be is 10.77. Now again, you might just be sitting there quite smug and thinking, I did not need to draw that graph. Why have you forced me into this creative process of graph drawing? I had 4 answers here. I know, I saw that 2 hours thing. I saw it 6:30. It's 6:30 plus 2 hours is 8:30, so I just crossed that off and we go with this one. I am amazing. That's all right. Again, I'm not here to judge you in your needs, and you would have got it right in this time. The problem would have been if, maybe if this point had come up. For some reason, depending on the wording of the question, maybe they would have said it can't leave until the evening, until 5 p.m. And you might have then said, well, okay, everything before 5 p.m. is out. We're just left with 1923 being the first thing. Well, no, because at 1923 after that, it dips below. So that would have been out of the picture. So it would have actually had to have been this one, the 22.77. So maybe that's too much. And I don't know. I don't pretend to be able to utterly convince you of the merits of drawing the graph in just a couple of seconds. Maybe I need to just pester on at you day in, day out, and we'll get you doing it. Because this is the way for the trig modelling questions to make sure you get the right answer they're looking for. I guess the last thing to do is it's asking for it in the earliest time the boat can leave. So it would have to be, to change it into minutes, 60 times 0.77 is 46 minutes, it looks like. So the actual time would be 10:46 a.m. That's just me converting the 10.77 into an actual time, because 0.77 hours is 46 minutes. So that's the answer. Absolute turbo recap, and then we're gone. They came to you. They gave you an equation that had a sign in it. They said this is modelling depth of water in a harbour. We trusted them. We went with them. We were sceptical. We're saying, why are these people coming to us with that? But we went with it. We worked out the height at the start when the boat comes in by plugging in 6.5, i.e. 6:30. Got some sort of answer. Fascinating. Then we cracked on, and we were told that the boat needs to be, well, it can only leave if the water's 3.8 meters high or more. And also, more than that, it had to be at least 8:30. So that's 8.5. So you're not going to get answers less than 8.5. Get rid of them. Get them in the bin immediately. So 2 things we were told there, yeah. Height of water and time's going to be 8.5. This was a big moment for us. It was a big moment in our lives. We turned the words into maths. We turned the words into an equation. We said that thing, which is the formula they gave us, it's got to be bigger than 3.8. Rearranged it, got this thing. And through our cast methods, or whatever methods we wanted, I guess, we ended up being able to draw this graph. I could just, well, label it T and Y, perhaps. Would that be good? Or T and D, just to really bring the point home. The squiggly line is the sine graph. That's sine 30t. This dotted line is the minus 0.6. We found the cutoffs by doing this in the normal equal way, the place where they meet, the intersections, and we wanted everything which was higher, I guess. That's our world. That's where the water level is higher than 3.8, corresponds to the solutions to this. Did a little bit of thinking about it, checked out our solutions, realised 7.23 is a disgrace. 10.77 was the first time it could leave. Translated it into the 24-hour clock. Bish bash bosh, 4 marks. Took a bit longer today. I get distracted sometimes. Not wholly going to apologise for it. Thanks very much for joining. Subscribe to my YouTube channel. Follow me on Instagram. I'm going to start posting topic-specific stuff. I'm going to start posting more questions for you to do. Get out of bed, all right? This is not bedtime. This is continual development time. Get ready for university. Get ready for when the schools go back. See you again tomorrow, 10 a.m. Thanks very much. Bye-bye.